is an attempt at new Linux distro for e-book readers. And just so we're clear on what we're talking about here, e-book readers versus tablets, the main difference is really in the display. Inside, ARM system on a chip, some RAM, some flash memory, but the display on these things is kind of special. So why are these e-readers interesting? Why should we care about them? Well, for one thing, these displays enable really low power modes. The electronic paper displays, they're reflective. You can view them direct sunlight. And these e-book readers have been kind of fairly widely distributed, which I'll get into in a bit. Here on the right-hand side, you can see an example of people using electronic paper for interesting stuff that's not just e-book reading. So this is a bus stop in Denmark out in the countryside with a solar panel on top. It's probably like 50 watts or less, and it's updating at least once a minute, showing when the buses are arriving. I assume there's some kind of cell phone thing inside of it that gets the data. And in Denmark, in the wintertime, December, there's 7 to 7.5 hours of daytime. And then on average, about 10% of that is sunny, is not clouded over. So they're able to do that with a solar panel in a situation like that. That tells you something about how low power this is. Some other low power applications, people are starting to do things like, or have for a while now, made these price tags that run off little battery cells that you can update remotely. So you can go on AliExpress and you can find these things. And one of the reasons they're so low power is that it only costs power to change what's on the display. So you put something on display, you can completely unplug it and it just stays the way it was, which means you can go into deep sleep mode every time you're not updating the display or doing anything with the processor. So some downsides to these kinds of displays. They are pretty slow to update. There's a lot of ghosting if you try to update them quickly. And right now there's no real color displays available. There are these things that have like black and white or gray tones and one color. I think I've seen them with red and yellow, but that's about it. And some of the earlier models, they didn't have good contrast, they didn't have any kind of light built in, but that's been solved. So what kind of companies are producing these? There's not that many companies, at least not companies that sell things you can actually get your hand on. It seems like there's only really two that I've encountered. One is the E-ink Corporation, and that's accounting for the majority of the electronic paper displays out there right now. Especially all the ones in the e-book readers, or almost all of them. And then there's Plastic Logic, and they specialize in these bendable displays that hopefully we'll see more of soon. So what are these electronic paper displays actually doing? How do they work? Well, if you ever worked in a biolab, you might have used one of these gel boxes, electrophoresis gel boxes. The idea with these is you can move proteins or other kinds of molecules through a gel by putting a voltage across the gel, and then they separate out based on how fast they move. And so the inside of these displays is actually these little balls, these little spheres full of some kind of oil with little particles that are black and white. And then on the top and the bottom of the where the balls are, where the spheres are, there's a way where you can apply a voltage. It's kind of like an LCD display. You have transparent conductors that allow you to put positive and negative voltage on the top and the bottom. And so if you put a positive voltage on the top, you get black. If you put a negative, you get white. And you can kind of do subpixel stuff. If you have more conductors and you have these spheres, you can get a resolution that's higher than the actual size of the spheres. And of course, you can make gray tones by mixing. Let me show us a couple of videos. Let me see if I can pull this over. So Scotty, down in the hardware hacking area, he had brought this nice microscope that we used to take a few interesting videos. Let me see. Can I get this to show up on the right display? Yeah, here we go. So here's under a microscope, you can see these little spheres. They're not actually perfect spheres, as you can see. But you can see these little things, and you can see what happens when you try to update. You can see there's a lot of remnants being left behind when you try to update the display, which is one of the weaknesses of these things. Let me do another one. So you can see it pretty quickly gets almost unreadable if you just update quickly and don't care about trying to make it pretty. All right. So why do you want to liberate these things? Why is that interesting? Why not just use them as is? Well, first of all, because free all the things. We should have control over what we own. We should be able to run whatever we want. Another thing is that there's a degree of corporate control on these e-readers. There's an interesting case some years ago where people had bought a book from Amazon, DRM'd ebook, and suddenly it just disappeared from their devices. Amazon simply revoked it because they realized they didn't have the rights to actually sell the book. It was kind of amusing that the book that they removed was 1984. But of course, so if that's a problem, I think they said they wouldn't do that anymore, but what are they actually going to do if they don't have the rights? I guess go out and buy them. The point is that they have that ability, even if they pledge not to use it. So you don't really own what's on your device, even if you paid for it. And then there's the aspect of DRM. You buy stuff off, let's say, the Amazon store, and a lot of it is DRM, so you can't share with your friends. That's terrible. And then surveillance. Several of these ebook readers, they actually log what you're doing, what you're buying, what kind of books you're reading, even how much time you spend on each page could be logged, and we don't really know if that's sent to the corporate overlords, but why wouldn't it be? And then, of course, these things are, at least for some companies that sell them, like Amazon, they're basically sold as a way to sell books, to sell ebooks. So there's a closed marketplace. So you can only buy from the company, at least on the device, you can only buy from the company that sold you the device. And last but not least, there's no way to install your own apps, which is terrible. We want to be able to use them for things that are not ebook reading. There's all these other things we could do with these displays and these little nice devices. So how many of these are actually out there? Well, it's hard to get numbers on this. Most of these companies don't publish any sales numbers. So I just searched around a bit, and I've got some numbers from Pew and some numbers from this site called Statista, and a lot of this stuff is just online surveys, so take it with a huge grain of salt. But at least for the first number here, we have some different numbers that are somewhat in the same ballpark, that maybe there's around somewhere between 19 and 32% of US adults who claim to own an e-reader, at least one. And then maybe about 72% of them are actually owning a Kindle. So that's quite a lot of people who own a Kindle. And then it seems like in 2011, the sale of these things peaked, and after that it's kind of been taken over a bit by sales of other devices like smartphones and tablets. So if we want to figure out which device that's the most commonly owned, maybe we should look at what was sold in 2011. And it seems like, I found this number for Germany, it seems like a lot more Germans have ebook readers than Americans. Okay, so what was sold in 2011? So for Christmas 2011, the current generation Kindles were these two things, the touch and non-touch version of the 4th generation Kindle. So maybe that's something we should look at. It's probably the most common one that's out there, and maybe also a lot of people upgraded since then, so maybe they're just lying around not being used for anything. So what's actually inside of these? Well, for the Kindles, if you look at it, every Kindle except the very first one are using these Freescale IMX chipsets. And if we then go and look at the Kobo, which is another company that makes e-readers, again, we see that, at least for the ones we have data for in this thing I stole from Wikipedia, it's all the same, Freescale IMX. And if we look at the Barnes & Noble Nook, previously they used other processors, but the last 2 generations, again, it's Freescale IMX. So why is everyone using this? Why did everyone go with the IMX? Well, prior to the IMX 5, I don't know why, people using it. But from IMX5 and up, the reason is very clear. It's because in order to drive these electronic paper displays, you need an electronic paper display controller or electrophoretic display controller. And they used to put those side by side with the chipset, so they need another chip for it, and they used to use these Epson ones, at least in the Kindles. But IMX5 and up, you can actually get these IMX chipsets, system on chip, that include the EPDC on the chip. So save a chip, that's great. The initial target I chose is the 5th generation, which is exactly the same as the 4th generation, except for the color, as far as I can tell. So let's move on. Let's put some software on this. Let's see if we can put some free stuff. Okay, first, what's available from Amazon? If there's any GPL stuff on there, they're supposed to make it freely available. So if you search around a bit, you find this website page on there's like the help section that says source code notice. It's not very well advertised, but it's there. And if we scroll down, we see for every single Kindle they ever created, there's a bunch of tarballs. Interesting. Let's have a look at that. See if I can see what I'm doing. I don't know how much you can see there, but let's just have a look at what's inside the tarballs. So here's the tarball from the 4th generation. And we see all these packages with well-known names, software projects we already use and know about. We see a U-boot, that's great, that's something we need. And then there's a Linux. Wait, that's a pretty old kernel, so well, that's probably not very good. But at least it's there. Looking at the next one up, the 5th generation release, there's this additional package, Awesome. I don't know if does anyone here use Awesome? Yeah, so the Awesome is a window manager and is very aptly named. It's very interesting. It's kind of a developer's, programmer's window manager, so I wonder why they're using that. Okay. Come on. What do we learn from source code? Looking around source code, we learned that it's developed by a company owned by Amazon called Lab 126. Why is it called Lab 126? If you look at the, oh, sorry, you can't see what I'm doing. Here we go. If you look at the Amazon logo, you'll see an arrow pointing from the A to the Z, and of course A is the first letter of the English alphabet, and Z is the 26th. That's where Lab 126 comes from. So, okay. I went to this recruiting event for people for Amazon in order to talk to them and figure out more about the system, and it's actually kind of a funny thing. I don't know if this has a name, this technique, but I put some interesting keywords that matched the kind of stuff I was interested in from Amazon, from the ebook readers on my LinkedIn profile, and then I waited. And then they contacted me and said, hey, would you like to come to this recruiting event? There's free beer. And so I went to the recruiting event and I talked to the engineers, and I was very disappointed. Well, there was free beer, but there are no Kindle developers, because they outsourced that entire department to India. So the code name for looking at this code, we learned that the code name is Yoshi, and there's all these interesting code names for the different products that are good to know. Then we also learned that there's 2 different versions. We just saw that a little bit with the Awesome being in one package and not the other. So they used to run everything in this terrible Java environment on top of a frame buffer, and then later they switched to using X with the Awesome Window Manager. All right, so let's get something actually running on. Let's compile the kernel first. So I downloaded the kernel. There are some header files missing, but like looking through all the tar files that they dumped, I found all the missing header files and like managed to put something together that actually compiled. It wasn't too bad. And then I made this system that lets you compile all this. So I put up on GitHub this thing where you can use VirtualBox, actually Vagrant. So you run like a command, it sets up the entire virtual machine that you need in order to compile everything. And then you enter into the virtual machine, and you run a build script, and it does everything for you. So these are the commands you need to do this. It's all on the GitHub. And then in order to compile the kernel, you need some kind of initial RAM file system. So I just used build root to make a really simple, tiny one. Again, all the stuff is there to build it really easily. Here's the commands to actually compile the kernel with the initial RAM file system built into the image. All right, so let's load the kernel. Let's see. Actually, it's not the one I want. Here we go. All right, so here I have a serial console, as I soldered 3 different pins to the inside of the circuit board. So in order to get a serial console, so I can experiment with what happens when you load the kernel, all this lower level stuff. But let me just get into the right directory. So this is the directory that you can put stuff in when you plug it into USB. It comes up as a USB storage device. So I just dumped the files that I needed on here. Oh, come on. And here, what I put on here is this kernel that I compiled, and I also put this other thing that I compiled, which is kexec. I don't know if you ever used kexec, but kexec is a thing that's part of the kernel and also a standalone binary. And if it's enabled in the running kernel that you can use kexec, then you can load a new kernel without rebooting. You can simply just do kexec, and then you do -L, and then the image that you want to load, and -T, and then you have to say what type of image it is. And then, oh, it'll load into RAM, and then you can do kexec again, and say, actually, now execute the kernel. And there you go, it's running the new kernel. So that didn't get us very far, because that was just a kernel, but at least it got us somewhere. Right, so let's talk about whether or not this is actually legal. In the US, at least, we have these interesting laws called DMCA, and it includes these things about circumventing copyright protection mechanisms. And it's illegal to circumvent copyright access control mechanisms, even if you're not trying to violate copyright, even if that's not your goal. It's illegal to produce these kinds of devices or programs or whatever you may call them, and it's illegal to disseminate. So there are some exemptions to these rules that have been added on. Every 3 years, the Librarian of Congress signs off on a new set of exemptions, and also hopefully the existing exemptions from the last 3 years or last many years, they can revoke exemptions as well. We have exemptions right now for phones and tablets. E-readers definitely do not count as phones and tablets. So you can jailbreak your phone and your tablet, but not your e-reader. And that's apparently because they don't see e-readers as general purpose computing devices, which, you know, I guess maybe they're not, but that's what we're trying to do here. So that sucks. Next update will be 2021. I hope to make a big fuss about this then. I unfortunately missed the last deadline to make a big fuss about it. So who do we talk to about this? Well, it looks like it's Librarian of Congress. So who's that? Well, it turns out this is a really amazing woman who's an actual librarian, not just a politician, as you might expect. And she used to be the president of the Baltimore Public Library, and has been vocally against the Patriot Act. It's like, how much better could it get? Of course, we can convince a librarian who's against the Patriot Act that we should be able to jailbreak these devices. But turns out that the Librarian of Congress is actually just signing off on these things, and who's actually in charge of figuring out, looking at all the public comments and figuring out what should be exempt is this person called the Register of Copyrights. Not the registrar for some reason, it's actually called the Register of Copyrights. So you don't have to read all this thing, but what's happening right now is that the Register of Copyrights used to be, or is currently assigned by, chosen by the Librarian of Congress. But our lovely government is trying to pass a law that will change this, so the next Register of Copyrights will be assigned by the President of the United States. So you could probably guess how that's going to go. Right now, the law is, it was passed the House, and it's been, assigned to refer to committee, so it's probably going to take a while before this goes through, but who knows? Who knows where it's going to go? So what is legal right now? Well, buying an already rooted device seems like it's not explicitly illegal. I look, at least not from me reading, I'm not a lawyer. I talked to some lawyers, I asked them, what do you think, is this legal? If I like go to Europe, where it's legal to jailbreak these, and then I buy a device that someone bought, used, that they jailbroke, am I breaking the law somehow? And it's like maybe it doesn't seem like it should be illegal, but it's not really been tested, so I didn't get a clear answer on that. Well, what if we just erase the entire flash memory and reflash it with a new system? Then we're not doing anything illegal, and the answer is that probably that's good. Probably they were okay. So, just to mention this, in order to do this KXEC thing, of course you have to cross-compile KXEC using the toolchain that's very similar to the toolchain used to compile the official system. So that's the only thing we need that for. So there's this Niluge, I don't know how to pronounce this. This person, Niluge, made a nice cross-compile thing so you can sideload things onto Kindle. So thanks for that. Just showing the serial console. Here's how you put a serial console on your Kindle if you want to experiment low-level stuff. Down there in the red square in the right corner there's some pins that you can solder to. These are the TX and RX. Here is, I've soldered a couple of wires up there, and I just soldered some other wire to ground somewhere. And the only thing you have to be aware of, it's 1.8 volt serial. I'm not going to tell you how to get further than that, because that would be illegal. You'll have to search the webs. Oh yeah, and in order to get down to actually get the case off, you can actually just brute force it off. You don't need any tools. You can just pull it off. The first time you do it, it's going to be really annoying because there's some glue on that big metal plate there. But even if you break off the metal plate, it's just protecting the battery. So just like brute force it off, it's easy. All right, so can we do something where we don't need the serial? Having to do all the soldering and connecting the serial is fine if you're trying to deal with U-boot and loading a kernel, but maybe we could make it easy for people to load things. Well, right here is some XML and some JSON, and the reason I'm showing this is some very nice people, including Tubob, Niluge, some other people who've been hacking on Kindle for a really long time. They make this thing called the Kindle Unified Application Launcher, and it's a thing that you can sideload onto Kindle running the official firmware, and then it creates like a fake book basically that you can access in your library. When you click it, it's a menu system, and the menu system allows you to launch scripts. So what's right here is just basically an extension for the application launcher that allows you to launch a fread that starts, or a script that starts a fread kernel using KExec. So let's just do that real quick. Actually, I did a pre-recorded video because I wasn't really sure it would be light enough to see it up here. Oh, actually, yeah, I'll do that. Okay, I guess it ended up sideways. I don't know if I can. Does anyone know the mplayer command to flip something 90 degrees? Okay, whatever. So there you go. See, it shows up as a book. You can click it, and then it loads this application launcher. It's very nice. You can add all kinds of funny things to your Kindle this way. You can sideload all kinds of stuff that people have made. And there you see, it's just, you can switch to fread. So when you click it, at first nothing really happens because you have to get to the point where you have some graphics. So, okay, we have a kernel, that's great. Can we just run Debian on this thing instead of trying to do something super custom? Let's just run Debian. I like Debian, it's easy. Turns out, you remember that really ancient kernel, 2631? That's a really old kernel. If you try to figure out what kind of kernel you can run with the latest and greatest Debian, the first thing you get is the Stack Exchange answer, of course. And you see that, well, actually for any other platform than x86, you need a 3.2 kernel. So for Debian 9, you need 222, but that's only on x86. So for Debian Jessie, of course, unfortunately, we can't run Stretch. We have to go to Debian Jessie, and that uses glibc 219. For 219, you you can actually do it with 2632, but if you recompile glibc with a different flag, then you can get it all the way back to 2627. So if we recompile glibc with another flag set, then we should be able to run Debian and Stretch. So I set up a wait. Okay, so the other thing we could do is, hey, why don't we just run a newer kernel? The IMX chipsets all have support in the mainline kernel, so it shouldn't be really that hard. So if anyone here is really good at kernel hacking, device trees, all this stuff, I'd love to work with you to get it running with the latest kernel. We will have to get support for the power management IC, the flash memory, a few other things, but it's not really too bad. For now, the only thing we have is a very simple device tree. It allows us to boot mainline kernel and get serial output, but nothing else, no flash, nothing. So for now, we're stuck with this kernel. So I compiled glibc with this flag. I made a little apt repository for all the extra things you need that are not standard Debian. And I quickly want to mention like cross-compiling. I've done a lot of cross-compiling for this project, and I hate cross-compiling. It's so complicated. There's so many things to set up and so many things that can go wrong. So just some quick tips. The first way to do it is to just set a bunch of environment variables and have a different cross-compiler, and then try to cross-compile every library one thing at a time and build up this like all the dependencies you need to actually compile the thing you want to compile. That can be really tedious for things that have a lot of dependencies and just takes a lot of time. My favorite way of doing it is this QEMU plus change root thing. I'll get into that in a second. And then there's some other ways you could do it. You can compile it straight on the e-reader, but you often run out of RAM. Most of these only have 256 megabytes of RAM. You can compile in the cloud. I ran into this issue where a lot of the cloud providers are using ARM64 cores that aren't backwards compatible with ARM32, and the e-readers are ARM32. That sucks. You can compile on like a cheap single board computer. That's a good way of doing it. Or you can compile on your phone. I bought a single board computer. I thought it was like, this is a really beefy one. I'll compile it really quickly, and then I realized it was slower than my phone. So maybe I should have just copied it to my phone and change root. All right, so just QEMU plus change root. This makes compiling really easy, and that's how I've set up the entire userland for this system. You can make you can do a debootstrap for a foreign architecture, and you can just sell it to only do the first stage of the debootstrap. It means it creates the entire root partition for a Debian system for the like an ARM architecture. You can do this on a laptop that's x86, and then with QEMU you can do this interesting thing where you just copy this little binary called QEMU ARM static into user bin in the new Debian userland you set up. And then when you change root into it, it automatically figures out whenever you run a binary to use the emulator. So it's transparent. You can just change root and suddenly you're in an ARM environment and it all works. Until it doesn't. So I was using this for a long time. When I was trying to compile glibc, I just got like, it basically just crashed. And there was some deep QEMU bug where it wasn't doing what it was supposed to do. I ended up having to just do it on an actual ARM core. Right, so here's the userland. Again, there's like a Vagrant setup, so it makes it really easy, and with a virtual machine to set everything up, you can easily add more packages and recompile everything and regenerate the userland for the system. It's a really minimal Debian, so I really stripped everything down. I got rid of all the manual pages. I got rid of, it automatically cleans all the app packages you download, and it gets rid of the app cache and stuff like that. So it's down to like 220 megabytes right now. You could probably get it further down if you need to, but it seems like a good size. There's 2 gigabytes of flash even on the older Kindles. Okay, let's get to the fun stuff. We need to get the display working. We can run and start a kernel. We can get some command line stuff working, but we need to get the display. So how do you get the display working? Well, you load the kernel driver, I assume. Then you would probably load some kind of X driver and maybe use the frame buffer driver, and that would be it. Well, turns out that's not exactly right. So we're very lucky that the GPL dumps included the EPDC driver. So if you look at some of these files down here, you can in fact see that one of them is called Lab 126. So this is some kind of driver they got from either Freescale or the E-ink manufacturer, and it's all licensed under GPL2 as the kernel is. And there's some enhancements by Lab 126. So that's not really enough. The EPDC driver doesn't operate on its own. It needs something called waveform. This is something that's specifically for electronic paper displays. They need waveforms. So I'll get into what these are in a minute. But they were very nice, and they also included like a test waveform that's enough to get at least basic output working for the display. And they did it as a .h file and licensed it under the GPL. I almost feel like there's someone working for Lab 126 that's trying to help us here. Okay, where do you get the actual waveforms to get a good result on the display? Well, it turns out that when you buy one of these electronic paper displays from the E-ink Corporation, this is the ribbon cable coming from the display from the front side. And if we look at this a little bit closer, you see there's a chip on there, and that's a flash chip. And that flash chip is not used at all during normal operation. But it is accessible from the pins on that little ribbon cable, or I guess not ribbon cable, but that little cable there. And you can talk to it and you can read what's on it. And it turns out it's kind of like the floppy disk with the drivers for the display. It includes the waveforms. So you can download these waveforms. And one of the additions that Lab 126 added to the EPDC driver is some code that lets you download that. So I didn't even have to write the SPI communication code. I could just like say, hey, please dump everything from the flash chip. So waveforms, turns out, they're lookup tables. And the way they work is you ask the lookup table, hey, what's the current mode? It turns out waveforms support different kinds of update modes. And then these these electronic paper displays, they're actually temperature dependent because it's particles moving through an oil. The viscosity of the oil and the speed at which they move changes depending on temperature. So you need to have a temperature sensor and know what the temperature is. So in the lookup table, you have to look into these, you look based on the temperature, and then you say, well, what's the current pixel value of the pixel I'm trying to change, and then what's the desired pixel value? And then after looking through the lookup table, it gives you these things called phases as the result. So what are phases? Again, the way the display works is this positive negative voltage that you apply, but you can't just pull negative to get the black particles top and positive to get the white ones to top. You have to ensure that you don't build up a charge differential on it, because that will screw up the display. So you have to be switching rapidly between negative and positive, and you have to do that in a way you get like the amount of gray that you need, the gray tone that you need. So you start with some gray tone, need some other gray tone, and based on the temperature and the mode, it gives you a set of these trinary values. That's what the phases are. They're just a set of trinary values. So it's either a 0, a 1, or a 2. And so a 0 would be pull the blacks, put negative on the top, and 1 would be put positive on the top, and the last one would be do nothing. So let's explore one of these waveforms, see what's inside of them. Here's what's in the header. We can see there's some interesting information about the display. It's an 85 hertz display. That doesn't mean that it updates 85 times a second. It means that the phases update. You have to send it a new phase 85 times a second. So if there's multiple phases, it'll be some fraction thereof. It's a 800 by 600, 6-inch. But then we look at the bottom here. It says, well, there's 7 modes and 14 temperature ranges, and it's a 4-bit per pixel display. That's good to know. So what kind of modes are supported? Well, this particular display's waveform had 7 different modes. And the first one is just panel initialization. Then there's a direct update mode, which is this kind of backwards compatibility mode. It's 1 bit per pixel. It's only monochrome. And then there's 2 modes that are like a high fidelity slow version and a high fidelity or medium fidelity faster version of this like flashing update mode, where it wipes everything white, then black, then does what you want. So it makes it really crisp and clear and wipes away a lot of that damage that we were seeing before. Then there's this very interesting animation update, and then there's 2 non-flashing modes. And then the temperature ranges that are supported, it looks like they support from 0 to 48 centigrade, which it makes sense that they support from 0 to 48 centigrade based on the fact that, you're probably not going to want to be using this above 45 centigrade because lithium-ion batteries don't like being charged or used at those temperatures. And then I don't know why they don't support freezing temperatures, but maybe the oil doesn't like it. Waveform phases. So looking at the actual phases, you see for each, so here's just looking at mode 4, the animation update mode that I thought was interesting. You see that there's like different numbers of phases for the different temperature ranges. So the first one is 0 to 3 centigrade. So if it's really cold, you need 22 phases, meaning it's going to take more time. And if you have something like normal room temperature, you only need 10. So the update speed is like twice as fast when you're at room temperature compared to if it's really cold. This is for the fastest possible update mode available. All right, so these waveforms, they come in a format. It's completely undocumented. I mean, there's documentation somewhere, but it's secret. So in order to dump all this information we just looked at, I had to reverse engineer the waveform format. It wasn't that bad because at least the header info I could kind of extrapolate from some of the structures that were defined, the structs that were defined in the kernel headers. And it turns out, not only was there undocumented format, it turns out that the format that these are stored in on the little flash chip is not the same as the format that the electronic paper display controller wants. They're similar, but it's a more expanded format that's less efficient storage-wise that you need to give to the ePDC. So I wrote this little tool called Inkwave, and the information we're just looking at, the human reader will kind of dump of what was in the waveform. Is one of the things that it does, and the other thing that it does is it converts from the format on the flash chip to what the ePDC needs. So what about these waveforms? Can we share them? Well, why would we want to? Because unfortunately not all of these displays include the waveform on a little handy flash chip. Some of the newer ones don't. I assume that they ship them to the people they make a deal with when they sell a bunch of these displays. I talked to some lawyers about this who know about copyright, and they said that it really depends on whether or not these are copyrightable, whether or not we can share them. Depends on how they're made. If they're made by a human doing some kind of creative work, even minimally creative work, then they would be copyrightable, meaning that they have copyright. We can't legally share them with each other. But if they're made completely with a completely automated system, then they might not be copyrightable, and we should be able to share them freely. We just don't know how they're made. So if anyone has any inside info on this, like how they actually construct these, that would be really useful. But worst case, we now know how the format works. We have a tool that understands and parses it. So with a little bit more reverse engineering, I'm sure we could make our own rig that just brute forces what the best waveform is for a certain display, just by looking at stuff with a microscope and hooking it into some computer vision stuff and writing a script. But worst case, we can still solve it. All right, getting the display working. So now we know a little bit more. So we need to read the waveform from the flash chip. Then we need to convert it. Then we need to load the kernel module for the ePDC, handing it the converted waveform when we load it. And then I assume we need to do some kind of X driver. I assumed we need to do some kind of loading of an X driver in order to get X working. All right, so there is an X driver. It wasn't in the GPL dump, but it was available from Freescale themselves. I found a bunch of patches, mostly from Buildroot. They had a bunch of patches for it that made it a little more modern. I added a little bit of work to make it work with the latest and greatest X server. And then I also found out that unfortunately it wouldn't compile because it was dependent on this Z160 library that's proprietary. But luckily, I was able to just pull out the dependency, and the only thing we lost was 2D acceleration, which honestly, the display is so slow, I don't think we're ever going to notice that. Turns out that's not all you need. When you load the X driver and you load the kernel module and everything, is about you start your X server and nothing happens. The reason why nothing happens is we're used to displays where you just write to the frame buffer or whatever you're going to do, and then the display updates. But electronic paper, you probably really don't want that behavior. If you have an automatic update on your display, then you don't have any control of what kind of update mode you're using. If you're using a clean, slow flashing update, or you're using a much faster, unclean update, or a dirty update. So when you're using something like the original operating system on the Kindle, the UI, you'll see menus and things that update quickly. They have to be responsive when you click around. And you'll see stuff like when you're paging through the books, it'll do a reasonably clean update, and then every 3 or 5 pages, it'll do a slower flashing update to kind of clear away all the damage that's built up, all these pixels that didn't switch properly. So the idea with with e-ink displays is that the application should be aware that it's e-ink and be intelligent and tell the system when to update. And the way this is implemented is that you actually just do these I/O control calls. It sounds kind of hacky, but you do I/O control calls that instruct the kernel driver. So, okay, whatever you have in the buffer, and now update, and you can tell it do the entire display, or you can tell it a square that you want it to update, and then you can tell it which mode to use to update, and then you can also wait for an update to be complete. There's other things you can do, but that's the core of it. All right, so it looks like this is what we need to do. We need to actually modify all the apps to issue updates via I/O CTL. That's really annoying. So as we saw before, there was one of these tarballs that had Awesome built into it. I looked at that Awesome and I diffed it against the same version of Awesome from the official repo, and it looked like they had added some things that allowed them to get X damage events. X damage events are from the X server. Whenever anything changes on the display, you can register for X damage events, and it'll tell you which square was changed. So they got Awesome to be able to get this event information, this X damage information, and that's all you could gather from that. But what they were probably doing is they were probably having some other code. So Awesome is scriptable in Lua. So it's very easy to add all these functionalities to Awesome using its Lua API, which is called Awful. It's not awful. It's pretty good. If you do this have this kind of patch, you should be able to write a little piece of Lua code that then every time there's an update triggers one of these I/O control calls and actually updates the display. And maybe you could even have like per app logic, which is Awesome support. So you can say like, well, this app should have this kind of update mode. This app should have this kind of update mode. Maybe you could even have some apps that are like semi-aware of the e-ink displays and tells Awesome like, hey, switch to this mode. Hey, switch to this mode. Or use this mode for the menu. Use this mode. So sounds like a reasonable thing to do. Unfortunately, their Awesome patch to Awesome is ancient, and so I just looked at their patches and I talked to the Awesome developer and I implemented the patches on the latest version of Awesome. So now we have these X damage event hooks. I compiled the Awesome against LuaJIT to get some speed, and then I wrote this tiny EPDC I/O control Lua library, and here's the little final piece of code for Awesome, where you can see I'm connecting to the damage signals for each client as they come up and for the screen itself. And then every time there's a damage event, it gets the area, and it does this ePaper update partial, which triggers the I/O CTL. All right, so let's look at this. Finally, we get to... Here we go. So now we can just run arbitrary apps, and whenever the display updates, it'll actually update. You see, oh, that was a short video. You can see that there's a lot of stuff left over because I'm using this really unclean, this dirty update mode, but you can switch that as you see fit. And just to see what I could get away with this really simple system that I ran some different demos. So you can see it's not terrible, you can get things moving pretty quickly. And this is not using the animation update mode I was talking about before. The animation update mode, when I tried it, it didn't do anything. So there must be some trick to it I haven't discovered yet. If we could get animation update, we get about twice the frame rate, much dirtier updates, I would assume. So I'm gonna try to experiment more with that going forward. Here is another little graphics demo. Yeah, so you can run stuff, but you don't have to care about what it is. And you see there's some weirdness going on where things are changing really quickly. You can switch to update modes if you want to get better results, or just experiment with what works for your app. All right, so here we are. We have the display working. We have everything working the way we want to, except maybe this EPDC aware app idea is something to be implemented. So the EPDC unfortunately has some limitations. It has a cool feature where you can actually do 4 simultaneous updates as long as they're not overlapping. So you can get a little bit more speed if you design your app around that. So this animation update mode, if we can get it working, the fastest possible rate is 8.5 hertz. It's not very fast, but it's something. All right, so let's see. Can we get to 100% free software? I showed using KXX on this Kindle where I have root access, but what if I didn't want to do that because I was worried that it was illegal? What if I just want to wipe everything clean and just have a completely free and open source software system? Looking at the IMX manual, which there's a really nice reference manual because Freescale is really nice about that. They publish documentation for their stuff. There's this interesting mode called the USB download mode. It's kind of oddly named because the person who wrote it is pretending that they're sitting inside of the chip on the Kindle and downloading things from you. So it's really like an upload mode where you can send it data. And the idea with it is that it's built into the ROM of the chip itself, of the Freescale IMX 508. And if you can toggle these pins, these two pins to the right setting, then when it boots up, it goes into this mode before it even looks at the flash, before it loads anything that was made by Amazon Lab 126. And then you should be able to give it your own code and boot into that. Well, how do we find these cheap out? Do we have to open it? Do we have to start our stuff? Well, if I was a developer, I would be really lazy. And I would just use some of the buttons so I could hold down some buttons when it boots. So I wonder if they did that. And of course they did. It turns out that it's not even two buttons. They already have one of the GPIO output pins just permanently set to the right setting, and the other one is the down button on the little 5-way keypad thing. So you just hold the power button for 20 seconds. You might be confused when you do this that it doesn't work the way you think it's going to work. You hold down the power button for 20 seconds. After 15 seconds, the light goes off. And you have to hold it for 5 more seconds. And then you press down the down button, and you release the power button, and you release the down button. And then if you look at the LS USB, you'll see that it suddenly doesn't come up as an Amazon device. It comes, or Lab 126 device, it comes up as a Freescale device. And then this nice company called Boundary Devices, they made this IMX USB loader open source program that implements that communication standard. So you can just use this to send like arbitrary binary data, and it just gets executed. Right. I was going to do a little demo, but I'm running short of time, so maybe we'll skip that right now. But what we can do is you can download that GPL dump, and the U-boot in there actually compiles cleanly. It wasn't missing any headers or anything, and it actually boots. So you can just recompile that U-boot, modify it however you like, and then add features to it, whatever. So this is I recompiled it as is without any changes, and then I used this USB downloader thing to to load it on there. And the USB downloader doesn't modify the flash. It just loads it into memory and executes. So you feel free to experiment. Looking at the available commands, it's very disappointing. There's almost nothing useful. There is nothing useful here. So, okay, now we have a U-boot, but how do we get further? So there's this file included, fastboot.c. That's interesting. Fastboot is the thing Android uses to allow people to reflash their devices, among other things. All right, limitations. The on-chip RAM is the tiny amount of RAM that's inside the chip. So it turns out when you're bringing up a system, you're booting a system, when you first start executing code, it doesn't have the RAM initialized. The RAM is an external device that needs initialization. So when you give it code, the first thing you have to do is you have to fit it into 72 kilobytes because that's all the RAM that's on the system. So you can see why they might have gone with this tiny minimal U-boot that has no features. That kind of sucks because if we try to add any features, we go across the 72 kilobyte limit. So I searched around a little bit to see if other people had looked at this before, and it turned out that on this forum, this person, Eureka, said that they actually managed to just like really hack away at it, all the features, and just only put in the fast boot feature and nothing else, and get a fast boot functionality working. And they were nice enough to post the patch. This is from 2012. I contacted Eureka, no response. Of course, this is a forum post from 2012. I was in a random forum, and they posted the patch as a forum comment, which got cut off because of character limit or something. So that's great. So after a long evening, I reconstructed the original patch, I think. At least it was working for me. So now you can get that off the fread.ink GitHub. And this other person called Nailush did a fastboot client, a really minimal fastboot client that has some changes allowing it to work with this modified tiny fastboot for Kindle. And so together, Yeah, I'm out of time. Together you can actually load U-boot with a fast boot. Once the fast boot is loaded, you have the ability to flash something, like flash erase all the partitions. So we should be able to use this to make like an installable image that just wipes everything. The only thing I need to change to get that, I haven't gotten there yet, the only thing I need to change the init ramfs image a little bit, and the init file, so that it actually uses the official partitions instead of doing this weird thing where it uses an X2 file or an X4 file in a file on the file system. So a few changes needed, but it should be easy for us to do this and have a legal, installable, complete new system. If anyone wants to help, you should contact me after this, or just like look at the website and go on the GitHub and try to compile everything. Just really quickly, Wi-Fi is one of the things that is a little bit problematic for these devices. It's not an open source, well, it's an open source driver, but there are HardMac chipsets in use on these things. So that means that they need not just the driver, but they also need the firmware that gets loaded onto the chip. That's pretty standard, but annoying, means it's not completely free software. But then on top of that, it requires a calibration data set. And the calibration data set, again, is one of these things where the copyright status is kind of like, who knows? But I talked recently to one of the kernel developers, the Linux kernel developers, works on Wi-Fi stuff, and they said that the community, or the community of kernel developers, had come down on the side of it's actually not copyrightable, and we should be able to freely redistribute it. And so they will accept pull requests with these data sets. So I'm going to issue one of those as soon as I get home. All right, what's needed to get to 1.0? Codename in Hedwana after the first author who we know the name of. Oh, and I'm cut off. All right.
Yeah, sorry, we had to steal your switch, but there's time for questions.
All right. Okay. So I only had a couple of slides, basically like what's working now. We have basic Debian, minimal Debian with graphics working. We have button input. We have USB networking. So once you load into it, if you have had connect over USB, when you boot into it, it'll come up as a USB networking device and give you an IP address, and you just SSH into it, and the password's freed. The dual booting is working, as you kind of saw. You can flash, but we don't have an image that's just like ready to go for flashing. And then Wi-Fi works with the little caveat that you need this data set, this calibration data set. And the thing that's missing is, in order to get this to a state where people can use it as their everyday replacement, is we need a little simple installer that makes the flashing process super easy. We need to port and bundle KO Reader. So KO Reader is this really nice e-book reading application that a bunch of people worked on and is actively developed, that you can currently sideload onto a Kindle on the official operating system. But in order to make it sideloadable, they did all this hacky stuff. And so we have to kind of strip all that shit out and make it into a normal application so it can run on a normal kind of system. It shouldn't be too hard, but if we get that, you should be able to use these as it's intended, an e-book reader, but running all free and open source software. I don't have USB storage device mode working. It should be pretty simple. Interesting things, someone gave me a set of patches that should enable USB on the go mode. I haven't tested them yet, but he claimed that they work. So again, it's an ancient kernel, but it should allow us to hook in like a keyboard and use it as a complete computer and just like have a terminal on and stuff like that. And from here on out, after that, I think the plan is just to support more devices, to get all the 4th and 5th generation Kindles, and then maybe some Kobos. So yeah, thanks to everyone who helped with this. Just if you have questions, I can't see if anyone's lined up for the microphone, but if you have questions, you should just get up to the microphone. While people are doing that, I'll just thank the free and open source software community, the EFF, Sycon, the awesome developer, Alex Papazoglu for U-boot help, Boundary Devices for their cool loader, Christian Hoff for the USB on the go patches, and Scotty from Strange Parts for the microscope access. Of course, also the Kindle hackers I mentioned before, Niluj, Tubob, and Eureka.
So did any of the Kindles that you played with have the 3G capability, and did you have any time to experiment with it?
No Well, I mean, I didn't actually check if they did. I have to strip out even the 2D acceleration, so I kind of doubt that there's any 3D acceleration left. If you're talking about like capability, of course, so you can.
3G wireless.
Oh, sorry.
Cellular built in.
3G. All right. So 3G is a good question. 3G is built into all of these Kindles. It's very limited. You can only use it for going through Amazon specific websites. Well, some of them are not. Some of them allows you to go on all websites, but it kind of goes through Amazon for that. There's been, in the community of Kindle hackers, there's kind of this unspoken agreement that people don't want to mess too much with that, because if people mess too much with it, they might just revoke it. And they've done that to some degree with other devices. So if we try to use their data for something it wasn't intended for, they might lock it down more or just get rid of it. That being said, I haven't really dug into it too much. It should be pretty easy to use the modem. The more interesting thing, I think, would be to replace the modem with something that you actually have a subscription for, so you could use it for any kind of data. Yeah, haven't looked into it too much.
So my question is whether you've heard of this, I think it's a Chinese-led project called Duocon. It was, yeah, I see you're nodding there, so I'll let you take over.
Yeah. I've installed Duocon on my device. It's unfortunately the source code is not available. It's a nice system though. It's also a thing that you kind of sideload as a secondary operating system for those who haven't seen it. And it replaces the closed Kindle operating system with a Chinese closed system that uses a Chinese ebook store. All right. Any other questions? It's hard to see here. That's one.
Yes. What I'm wondering is, I currently use a slightly older Kindle, a Kindle keyboard, I think it's 3rd gen, if I remember right.
Yeah.
And I don't necessarily care about having it totally opened, but I'd love to add a couple of ebook formats to it. Because one of the annoying things is you can read Mobi, but you can't read EPUB, which the rest of the world seems to prefer, and having to convert things is a royal pain in the rear.
Yeah, I mean, if you wanted to do completely free and open, then the problem with the anything before the 4th generation of Kindles is that it's using a different EPDC. It's using something called the Epson broadsheet. If you just want to sideload something onto the existing operating system, the KO reader that I talked about before is an amazing e-book reader application that supports basically every format. It does insane things, like it has a really good OCR system built in. It can figure out, using libraries other people have written, it can figure out even scientific articles with multiple columns to reflow those into single columns, all kinds of cool stuff.
And that'll work on that series?
Yeah, you should be able to, well, you have to have a root access to your, illegal root access.
Well, how would I have that on Series 3?
So, yeah, you should be able to sideload that. All right, well, thank you.